In 2023, air travel produced 882 million tons of CO2, equating to 2.05% of carbon dioxide emissions from human activity for the year. Aviation represents 12% of all CO2 emissions from transportation and 3% of total human-related climate impact. While these statistics may not seem significant alone, global demand for air travel is predicted to double by 2040. Addressing an accessible element of our emissions is a small step toward environmentally friendly transportation and benefiting our whole planet's natural world. Fortunately, the aerospace industry is currently working on advancements in sustainable aviation, making progress with lower emission fuel and emission-free options like battery-powered planes and hydrogen fuel cells. Sustainable aviation fuel, or SAF, is an eco-friendly option that can reduce greenhouse gas emissions by 94% compared to traditional fuel. It can be made from a variety of materials, including food and yard waste, wood biomass, fats, and oils. Used cooking oil has been studied as a viable alternative to conventional fuel because it can be recycled into a renewable fuel source. McDonald's fry oil could carry you across the world. SAF is not completely emission-free and requires more specific ingredients. It burns 20 to 50% cleaner than petroleum-based fuel and could be implemented today. SAF works with any passenger jet right now. Battery-powered aviation is a growing field of research. Its main benefit is a completely emission-free flight, making it a cleaner option than SAF. Batteries, however, quickly become too heavy and too warm to function in an aircraft setting, confining battery technology to short-haul routes with few passengers. Battery-powered aircraft can work in conjunction with other sustainable technologies that could cover long-haul flights, but to become a widespread and practical solution, they must scale up to suit larger planes. Hydrogen fuel cells are another emission-free option for sustainable aviation, potentially a more reasonable option for a wider range of applications. A fuel cell generates electricity with an electrochemical reaction rather than fuel combustion, and its only byproducts are heat and water. As long as hydrogen is provided, the fuel cells will continue to function and do not need to be recharged. Fuel cells are used in other modern applications like power for homes, businesses, hospitals, and data centers. They also propel other forms of transportation, from cars to forklifts to trains. The main drawbacks to hydrogen fuel cells are space and cost. The power density required by an aircraft demands lots of fuel cells and large hydrogen tanks, creating concerns for space and weight of the plane. On the other hand, hydrogen fuel cells contribute to zero-emission aviation because they are completely carbon-free, reducing the cost for environmental damage later in time. In response to the growing demand for environmentally friendly transportation, the aerospace industry is developing a variety of options to transform flight into a sustainable and emission-reduced format. Sustainable aviation is a complex problem that will likely not be resolved with simple technology, so continued development of many approaches is the best step toward a cleaner future.